Hello everyone. Today we are going to learn logistic regression and Probit regressions. In short, it is known as the Logit model or Probit model. So we are going to learn today logistic regression or it is called Logit model. Logit model. And another one is going to Probit regression or Probit model. Let me write just one. Probit model or Probit regression. Probit regression. So these are the two things we are going to learn today. So let me start with the logistic regression one. Okay. So in order to understand that, first of all, we need to know what is odds and what is odds ratio. These are the things we are going to use in the logistic regression. So suppose there are 100%, in this 100%, suppose 30 is smokers, and 70 is non-smoker. Okay. So then odds of smoker, how we define odds of smoker? So odds of smoker is defined as how? 30 over 70. This is what. And odds of non-smoker, how it is defined? Odds of non-smoker in opposite way. Non-smokers in opposite way. 70 over 30. Okay. These odds can also be defined in terms of probability. How? Take a look at that. How we can define this in terms of probability. In terms of probability, this is defined as probability of smoker out of 100, 30 smoker, probability of non-smoker out of 100. So this is the probability of smoker. This is known as the probability of smoker. This is known as the probability of non-smoker. Okay. So you understand what is odds is. Now we want to do odds ratio. We want to explain what is odds ratio. After that, we will go, because these log of odds are used as a dependent variable in the logistic regression. Log of odds. Okay. So let me start with the what is odds ratio. So there is a odds ratio, odds of smoker between male and female. Okay. So between male and female. So here you can find the odds of female smoker and odds of male smoker. This is odds of female smoker, and this one is odds of male smoker. Okay. So out of like 100 male, suppose 70 is non-smoker and 30 is smoker. Out of 100 women, suppose there is 15 smoker and 85 non-smoker. This is the odds of female smoker. This is the odds of odds ratio of smokers. Odds ratio of smokers. So in that case, if this odds is less than 1, so female smoker is less than, if If this value is less than 1, so odds of female smoker is less than 1. If this value is greater than 1, then odds of female smoker is greater than 1. So that's the way odds ratio is defined. So in logistic regressions, how can we define our dependent variable? Dependent variable is defined by P over 1 minus P. This is the dependent variable, log of odds. So this is the P and this is the 1 minus P. So that is the way in logistic regression dependent variable is defined. In Probit model, dependent variable is defined like this, like G values. So inverse normal G values that is coming, which I'm going to discuss theoretically shortly. Okay. So after discussing this basic thing, in logistic regression, we will use log of odds as the dependent variable. On the other hand, in Probit model, we will use inverse probability function of normal distribution as the dependent variable, inverse probability value or cumulative distributions value less than. So we are going to discuss that now theoretically. Okay. So let me start theoretical parts in here. I don't want to go write all of these things. If I write all of these things, it will take almost 2 hours. So I just don't want to waste the time. Take a look. A logit function can be written as logit P log of P over 1 minus P. And then this is denoted as a Z, and this is a linear combination of the covariate and the parameter. Beta 0, beta 1, beta 2, beta k, and x1, x2, xk. These are covariate. Beta 1, beta 2, beta k are the coefficients. So now, in this term, if this is a log of this, if log is the opposite of exponentiation, so I took this log from here to right side, it become e to the power z and p over 1 minus p. So now if I do the cross multiplication of this, then I got p equal to e to the power z minus p to the power z. And finally, if I want to find this value, then I got p hat equal to e to the power z over 1 plus e to the power z, which we can obtain equal to 1 over 1 plus e to the power minus g. If I multiply these things by e to the power minus g, this is the way we can get the value. Okay. So you have understand how to compute, how to express my P in terms of this. So this is what we are doing modeling. And in this case, x1, x2, xk are the covariate, which I know. Now we want to have a knowledge. We have to have a knowledge of Newton-Raphson method. Why? With Newton-Raphson method, we can estimate the probability. If we do not know Newton-Raphson method, we cannot estimate, if we know the Newton-Raphson method, then we can estimate the parameter of the logistic regression as well as Probit regressions by numerical approach. Analytical value, that means theoretical derivations, very beautiful derivations of the parameter estimate is not possible in logistic regression as well as in the Probit model. Okay, so we need to understand what is Newton-Raphson method. The Newton and Raphson, this is the original Newton. In 15th century, they give this formula in order to estimate the value of a function if that function satisfies two conditions. One is continuity and differentiability. So suppose you want to find the value of the x which satisfy the equation, right? So then what you do, you take initial guess, x0 is the initial guess, and fx0 divided by f prime x0. And then in this case, if you do the iteration one after another, at one stage, you will get a stable result, convergent result. So the result will converge. To find a root of a continuous differentiable function fx at point x equal to x0, Newton-Raphson method tells us that a better approximation for the root is x1 equal to x0 plus x0 minus fx0 divided by differentiation of fx0. So you take initial guess x0 and then you find the x1 and then plug this x1 value in the x in order to get x2, and then again plug the x2 value in order to get the updated x3. This is the way it will continue up until in here. Okay. So now the question is, why should I believe this? Someone writes some formula, then we have to believe this unconditionally? No, there is a rationale. What is the mathematical rationale for that? This is what we are now going to understand. So we know that tangent of a equation is y equal to f prime xn. Xn is a point, and then x minus xn plus fxn. So this is the tangent of a equation. Okay, now we are plugging y equal to 0. If I plug y equal to 0, in this case y equal to 0, and xn takes below xn plus 1. So when this, in this point, if you take a look at that, in this point, in this case, let me see if I can make it bigger. So let me see, select. I want to do in here. I want to make the size bigger. Let me see if I can make the size bigger. Add pen. Highlighter. Let me see. Okay, I cannot make the pen bigger. Okay, so take a look at that. This is the point where y value is 0. So I plug y equal to 0 in here. If y equal to 0, x equal to what? X and plus 1, which I plug this. Instead of this x, I put here x and plus 1. Okay, x plus 1, and then and then xn, which is the original value, and then fxn. Now if I solve this, x plus x and plus 1 can be obtained by doing these simple calculations. Okay, so how Newton-Raphson give this approximation formula for any functions that is continuous and differentiable? What is the continuity and differentiability? So continuity definition is that if we make a very tiny little change in the argument x's, then in corresponding to that, we will get a very tiny little change in functional values. That is the way. So it is like written, continuity of a function is defined like this. If continuity of a function defined like this, if x minus y is less than very small epsilon, then fx minus f of y, their change is also very small. This is defined as a continuity. Okay, so if a function is a continuous and differentiable, then that function that function has a solution. How can we find that solution numerically? This is the approach. So you got initial value, then if you continuously update the value, then you will end up with this value. Okay, now come there example. In this case, fx equal to x square minus 4x minus 7. Okay, in this case, if I find the first derivative, then we are getting twice x minus 4. Then start with x0 equal to 5. If I plug x0 equal to 5, then we got this value. How? X0 equal to, I plug 5, then fx0 equal to 5. When I put, we got 25 minus 20 equal to 5. 25 minus 20 equal to 5. 5 minus 7 equal to -2. Here we got -2, and here we got 10. 10 minus 4 equal to 6. -2 over 6. So -2 and 2, +2. +2 over 6. +2 over 6 equal to 1/3. X0 equal to 5. 5 plus 1/3 equal to 0.333. So we got this value. Okay. So and then again we update again. We again take this x1 value, again plug it in there. Again x2 value, we plug it in there until we got a convergence result. Okay. That is the way we can get the solution of any equation which is continuous and differentiable. Only limitation of Newton-Raphson method is initial guess. Initial guess will be very bad. Then you might end up with unstable and divergent results. You would not get. For example, suppose you are doing economy of a of a small country like Bhutan or Bangladesh or Nepal, right? Their economy is just like 40 billion or $50 billion economy. So we have equations that we want to optimize, we want to solve. In that case, if we put initial guess as $1 trillion, which is way higher than the initial guess, you will end up with a wrong solutions, or maybe you will never get any stable solution. So only one thing we need to remember: Newton-Raphson method give us very good result if the function is continuous and differentiable, and next initial guess should be very good guess. It should not be very bad guess. Okay. After that, now I want to show you the mathematical derivations of the logistic degree regressions, how these beta 0, beta 1 parameters are derived analytically, and after analytical equations, how can we obtain those value by numerically. So there is no very closed format, beautiful functions of this format. Okay, take a look at that. Derivation of the logistic regression. Derivation of the logistic, suppose yi equal Bernoulli, phi xi as its parameter, where probability of y1, y2, yn equal to this. And now phi xi divided by 1 minus phi xi equal to this. This is what. So now your question, why I am defining this equal to that, right? Why I am defining this equal to that. Take a look, how did I define this? You remember that has been defined like that way. P hat is the probability of smoker. Okay, probability of smoker. So what we got in here, this is probability 1 over this probability of smoker. So that is what is called the probability. Now, this probability is we are considering as a Bernoulli distributions probability, which has a response variable yi. Yi equal to this as this parameter, y1, y2, yn equal to this. Now, as this is the definition of the Bernoulli distributions. Bernoulli distribution has a parameter pi. So we are finding the likelihood function of the Bernoulli distributions, and we got like in this format. So now in this format, if I write phi I over 1 minus phi I, so that means if we write like this way, this phi I divided by 1 minus phi I, after doing all the mathematical computations, we got this format. So if you plug this value, after doing these things, now we went back to the original, this formula, we went back in here, and then after went back in there, we brought something in there and left something in there, we got this format. This is a mathematical format. After getting this mathematical format, then we can rewrite this in this beautiful format as well. So we finally got this formula. Okay, now take the log likelihood. So this is the likelihood functions. Now I'm taking log likelihood. If you take the log, it looks like this format. And after differentiating it with respect to beta 0 and beta 1, we got these two equations. Equation 2 and 3 will not yield analytical solution for beta 0 and beta 1. Newton. So from this equation 2 and equation 3, we will not get any analytical solution. So what do you mean by analytical solution? Analytical solutions mean very beautiful closed format mathematical expressions of the solutions, where we will plug the value and get the results. Okay. For example, suppose if you have a beta hat, so beta hat equal to could be written as sum of xi minus x bar, and then it is written yi minus y bar, and then sum of xi minus x bar square. This is the analytical solution of the beta 1. In this case, if xi and yi values are given, from there I can compute xi minus x bar, and then I can compute yi minus y bar. This is what I can compute, and then I can multiply this and that to compute that one, I can square this and compute that one. This is called the analytical solutions. This analytical solution, very beautiful closed format analytical solution, is not possible to obtain. So what we need to do, equation 2 and 3 will not yield analytical solutions for beta 0 and beta 1. Newton-Raphson methods needs to be applied for the solution of beta 0 and beta 1. So Newton-Raphson solution is x1 x1 minus fx0 divided by this. Step to estimate beta 0 and beta 1. Impute initial estimate value of beta 0. K plus 1 iteration value is obtained by using this formula. In order to obtain this I beta k and u beta k, we have to follow this. U b equal to first order derivatives and I b equal to second order derivatives and second order partial derivatives. And then we finally got these two values. Now, in this case, if I plug all of these values together and then keep using this value iteratively, then we will end up with the solutions of the beta 0 and beta 1. And if there are more parameters, then more. Okay, so that is the mathematical way to numerically estimate parameter of the regressions coefficients. Okay, that is the way. Okay, now let me tell I want to discuss now Probit model. In order to go to the Probit model, let us first discuss what is the difference between these two models. So difference between Logit model and Probit model. The Logit model is used to model the odds of success of an event. However, the Probit model is used to determine the likelihood. Likelihood means probability that an item or event will fall into one of a range of categories by estimating the probability that observations with specific features will belong to a particular category. So here we want to find the probability that it follows a range of categories. So that is the difference. So let me start from there. Probit model. That is the way Probit model is defined. Probability of y equal to 1 given x is denoted by the capital phi z. Phi z is written like that way. So now, as you know, this is the normal distribution. This is the normal distributions. Sorry for my bad drawing. This is the normal distributions. So now this is the normal distribution. If you take a look at that, this is the normal distributions. Now it has been written in here, suppose -2 in here, or like the 2 is in here. So now phi of 2, that means this probability, this all probability, okay, phi of 2, phi of z. It was written there as phi of capital Z as written. So this is equal to that. So phi of -2 is phi z, which could be like this, -2 like this. This is the probability. Okay, so you understand the Probit model can be represented using the following formula, where y is the dependent variable and represent the probability that event will occur, hence y equal to 1, given the variables x. Phi is the cumulative standard normal distribution and z is the linear combinations of independent variables. G is the linear combinations of independent variables. Okay. Difference between Logit model and Probit model. The Logit model and Probit model difference I already said to you by giving the complete explanation. By giving you the complete explanation where to use. Now I am going to derive the how to estimate the Probit model. That procedure I am going to show. So Zi is a xi beta plus epsilon. So this is a Latent variable Zi we define, and then Yi is a 0, 1 dichotomous variable. If Y equal to 1, that means event happen. So that means Zi greater equal to 0. And then if Yi equal to 0, so that means Zi is less than 0. So that is the way Yi are defined. After defining Yi, we have to compute this probability in this format. Probability of Yi equal to 1 equal to xi could be written as probability of yi equal to 1, yi equal to 1 is exactly equal probability of zi greater equal to 0. So this condition is exactly equal to that condition. Again, zi equal to xi plus beta. So we plug here xi plus beta. And then we put epsilon equal to greater than epsilon equal greater than xi minus beta. So which could be written as epsilon I greater equal to this is exactly equal to less equal to that. For example, let me show you what does this mean. As this is a symmetric distribution, as that is a symmetric distribution, this is equal to 2 and that is equal to 2. Okay, take a look. Greater equal to 2 means all of this area, all of this area, all of this yellow area, greater equal to 2. Now, less equal to what? Less equal to 2 means all of this area, all of this area. So that means the probability of this yellow area and green area are the same. So that's the reason these things has been written. That's the reason these things has been written. These things has been written. That's the reason these two things has been written. Okay. That's the reason these two things has been written. Oh, fantastic. That's the reason these things equal to that thing. Okay. That's the reason these things equal to that thing. Well, so and these things can be written as a probability distribution function or cumulative distribution function. Cumulative distribution function. Distribution. This could be written as cumulative distribution function. Okay. So now cumulative distribution function has been written there. Okay. Cumulative distribution function has been written there. Now, as we find f of, here we find f of y equal to this. Now here we can find uh, f of yi equal to 0 equal to this one. This is what we can find in there. Okay. We can find these things in there now. Okay. So now here y equal to 1 we found. Now here we found y equal to 0. So in this way now likelihood function can be written like that way. Previously likelihood function was not written. Now the likelihood function is written likelihood function is written in terms of to the power yi. Here it is written 1 minus cumulative probability. So this is the probability in here. Also, that one was also probability in there. When we derive these things, take a look at that. That one is also probability in India. This is probability, that is probability. Phi x equal to this. This is the probability that I discussed. Okay. Okay, so after doing this, now we have to, in order to do some mathematical, in order to do some mathematical, in order to do some mathematical, in order to do some mathematical manipulations, we have to assume qi equal to yi minus 1 and qi equal to 1 if y equal to 1 and qi equal to minus 1 if y equal to 0. So this condition reduces these two things. Okay, if you plug this value and match these things here, and then likelihood finally reduces like that way, and from there its log likelihood goes like this way, and after go log likelihood, if you plug the value, if you plug the value of the qi that you assume in there, it will be like this likelihood and log likelihood. It should be like that way. It should be like that way. Okay, it should be like that way. So if you do not understand these things, if you do not understand these things, just let me know. Okay, I will be more than happy to clarify these two things if you do not understand. So what they are doing now, two term reduces to only one term. So if qi equal to 1, then xi beta is getting is then. If qi equal to -1, then fx negative beta. So that means this is the same quantity. We are writing negative and positive part, because take a look at that. In this case, if you want to write it in here, in this case, if you write it in here, you will see this. You will see this part, it exactly equal to that part. So that is the rationale they have written this one like that way. Okay. After that, now come to that. These two equation has been found. Now we have to find the score functions. After finding the score functions, we have to find the Hessian matrix. That means second order derivatives. After doing the second order derivatives, then now need Newton-Raphson methods. That's the way we can obtain the solutions for the functions, for the logistic regression, as well as for uh, Probit regressions by using Newton-Raphson methods. Okay, that is all about like theoretical discussions. Now I am going to discuss about about your probably homeworks, as well as how these applications is happen and corresponding the R code. Okay, so let me go to the homework. In this homework, what you will have to do, in this homework, please read these two documents thoroughly. Okay, these documents thoroughly, read these documents thoroughly, and then what is written in this document, you have to write a report similar to these two documents for logistic regressions and for Probit regressions. Okay, so this is a Probit model problem 2. This is a logistic regression. So if you read these two documents thoroughly, it will take you maybe not more than 30 minutes. Okay, in order to understand that. In order to understand the theory and handwritten derivations, watch my this video and also read the theory, how logistic regression and Probit regressions are derived. And then you must write a report in Word document about your findings. I have not purposely provided Python code for this homework. Instead, I provided you R code. Okay. As 4 lectures is done, enough preparation, enough training on the Python are given to you. Now I ask you, advise you, and order you to do this 5th homework by using Python Jupyter or Python Spider. If you really struggle, then you can just copy and paste my R code that I'm going to discuss now. In this homework, I purposely provided R code, not Python code, in order to see whether you can write the Python code. Understand? If you really struggle and do not know, then just copy and paste my Python R code, and on that R code, change the variable name, data name, which I'm going to show you. Okay. So this is about the homework. So in logistic regression are very useful and important in real life applications. How this regression is very important? Because for example, most of the time in our life, we are happy with only one success, right? Job, no job. Interview, no interview. And then getting a success of buying a car, no car, car, no car. And then buying a home, no home. And then disease, no disease. Default, no default. Bankruptcy, non bankruptcy. If there is a situations you want to predict yes and no, that means 1 on 0. Probit model and logistic model are the tool that you are going to use. Remember, the finance industry, also healthcare industry, they need to know how to use. They need to know how to use this Probit and Logit model in order to predict the outcome of an event. So whether disease, no disease. Okay. So very important model of this one. So our sixth lecture, maybe or maybe seventh lecture, I will do another model which is known as the Cox model for risk assessment. So time to event, how long it take for the company to bankrupt, right? Time to bankruptcy and time to default, something like this. Time to disease, time to have an event. Okay, so you understand. Please read these two documents I have provided. This is the easiest, most easiest document. Okay, in order to understand Python, in order to understand logistic regression and Probit regression, most easiest document are these two documents. Okay, now let me click one of these. Probit regression is opening, I guess. Yes. So let me start with the logistic one first. Then, okay. I will do only one thoroughly. The rest, the Probit one, I will not read, and Probit code I will not run. I will read just only one of these things. So in order to make the video shorter. So if I make a very long 2-3 hours video, maybe you will be bored. Okay. So take a look. Logistic regressions, also called a Logit model, is used to model dichotomous outcome variable 0 and 1. In the Logit model, the log odds of outcome is modeled as a linear combination of the predictor that I showed you previously. So now, two examples we want to show in there. A researcher is interested how variables such as GRE, graduate record exam score, GPA, grade point average, and the prestige of the undergraduate institutions affect admission into graduate school. The response variable admit, do not admit is a binary variable. Now, for our data analysis below, we are going to expand on example 2 about getting into graduate school. We have generated hypothetical data. This is a hypothetical data generated, which can be obtained from our website within R. And note that R requires forward slash. This is called the forward slash. The slash that started front and go back is called the forward slash. The slash that started back and go forward is called the backward slash. Okay, backslash, forward slash. Okay, so this is the data. So let me go to the R. Let me go to the R. So these are the packages you sometimes need to install. Okay, so okay, what is R? So let me show you what is R. Let me spend some time in order to clarify what is R. If I go there, if you type here, download R, then R will come, click in there. For Windows computer, just click on there, click in this part, then it will be downloaded. Okay, after downloading the R, you have to open the R, right? So let me close it first. Let me close it first. Let me show you how to open the R. Save workspace, no. So R has been closed completely now. Then there is also, is called the R Studio, which is similar to the, this is called the R Studio, which you can also download, do not save. So R and R Studio are the same. Now I want to show you, suppose you click in there and R is downloaded. How can I open the R? So I want to go there. Okay, I want to go somewhere. Okay, where is my Windows tab? Why Why all of this is showing in there? File, exit, quit. Yes, quit. On the navigator, yes. Okay, so now because of that navigator, I could not see this. So now click on this Windows button, and then you can come here, R. You can find R in there. You can find R in there, and you can click on there, and then R is open. Okay, now R is open. I have said that I have a R code that I have provided, right? So let me open that R code. I go to the file, open, and then I go to the week 5 R code Logit and Probit. It is open. Now I go to the Windows. I go to the Windows and tile horizontally. So now this has been put. So now let me install that library first. In your case, you have to do it like this. First of all, install .packages, because I already installed it. So I don't need to install it again. I just run the library. That's it. So I don't need to install, but in your case, you have to install these things. So this is called the Windows or Mirror, which one you choose. If you live in Illinois, you choose Ohio. If you live in New York, Missouri, Michigan, Iowa, I think you can choose Ohio. Okay. If you live in the, but the few people I have seen, they live in USA, but they choose the UK, London one. Why? Because that is the hub. This is what people said, like the R programmer. So that is it. But I choose Ohio one. So let's choose the Ohio one. Okay, it has been installed successfully. Now go to the library. Library, it has been installed, library one. Now I want to install these two packages. So that one also I want to install the library. So now I want to read this data, my data. And now if you take a look at the data, head, my data. So this is the data, okay? I will give this data to you people, okay? So you will have to change. For example, in your homework data, suppose you do not know how to use Python to solve this. I highly recommend you. I will be super happy if you can solve this homework by using Python. Python code I purposely did not provide so that I want you to do this homework by using Python. So that is why I did not provide the Python code. So this is your data. Just go there, right click in there and go to the properties and click this link, week 5, and then come in here and go to the R and then paste it in there, put this and then change it backward slash to forward slash, backward slash starts from back. And then I have to write the name of the data, which is equal to, this is the name of the data, properties. Rename. I copy this and then I want to put it in there in .csv. Okay. Now if I hit Control R, data is run. You can run each line of code by control cursor blinking, and you hit Control R, the letter R, Control R, letter R, it will run. Okay. So now your homework data is run in there. Okay. Now this is the way you can do the solution for the homework 5 by using R if you do not know how to solve it by using Python. Okay, let me move forward. So our data is my data, which is this, and then this data looks like this format, and then I want to check like the frequency of this data. So rank 1, 2, 3, 4. This is the rank variable, which has a 4 ranking. So ranking 1 is the best college, ranking 2 is the second best, ranking 3rd is the third best, and ranking 4 is the worst colleges. Bachelor degree provider, undergraduate degree provider colleges. Okay, 0 is admit, 1 is 0 is no admissions, and 1 is admission. So in that way, this is what we got the cross frequency. The rank is not in a if you take a look at the structure of the data, if you take a look at the structure of the data, which is equal to my data, you will see the rank is written as an integer variable. Rank is written as an integer variable, okay? But I need it to be a factor. So that is why we run this code and it has become factor now. After running factor, now I run the GLM. So here, GLM logistic regression. See, one line of code. That is why become a coder is very essential. One line of code you have run and then your results is in there. So what does this means? Admit is a dependent variable. Admit is a dependent variable. GRE and GPA and rank are the independent variable. GRE and GPA are the continuous independent variable. Rank is a qualitative independent variable. Data is my data, family equal to binomial. So this is what this is what like my Logit data. Now, if I want to take a look at the output, this is the output. Now, how can we explain this output, which I am going to discuss from the handout? Where is my handout? That link that I have provided. Let me see. Maybe it is in there. Logit model. Yeah, this is what the Logit model, right? We are. No, I don't want this one. I also do not want this one. Yeah, let me go there. This is what I was looking for. Okay, so we have done these things. This thing is done. We got this summary statistics. We got this rank. And now this is the explanation. I ask you, I advise you, I humbly order you, please read these two documents. It will be altogether not more than 30 minutes reading. And then you will understand how to explain the output from these two models. Okay. So now take a look. We got this output. We got here median is not equal to 0. If median equal to 0, so that means our error residuals is normally distributed, but it is not. But it is approximately normally distributed. Anyway, so how can we explain these things? Come here. In the output above, the first thing we see is the call. This is the our reminder. Are reminding us what the model we ran was, what options we specify. Next, you see deviance residual, which are measure of model fit. This part of output shows the distributions of the deviance residual for individual cases used in the model. Below, we discuss how to use summaries of this deviance statistics to assess the model fit. At the end, we will take null model and with all the parameters to show the differences at the end. So now next step is from here, the parameter explanation is mentioned in there. This is what you need to read thoroughly in order to write the comments and reports, mention those in your report. Okay. So here, the next part of the output shows the coefficients, the standard error, the Z statistics, and the associate p-values. Both GRE and GPA are statistically significant, as are the three terms for rank. The logistic regression coefficients give the change in the log odds of the outcome for a 1 unit increase in the predicted variable. So take a look at that. So both GRE and GPA are statistically significant. Why? Statistically significant, GRE and GPA, their p-value is less than 0.5. So that is why they are statistically significant. GRE and GPA are statistically, both GRE and GPA are statistically significant as they are as are the three terms of the rank. So three terms of the rank, these are also significant. So all parameters, p-value, and their all estimates of the parameter with their corresponding p-value less than 0.05. So that means they are significant. So intercept, GRE, GPA, and rank 2, 3, 4 are significant. Why rank 1 was not put in this output? Because rank 1 is the reference category. With respect to reference category, there are three comparison category, which are rank 2, rank 3, rank 4, and we compare between them. Okay. Now, the logistic coefficients give the change in log odds of the outcome for 1 unit increase in the predictor variable. For example, for every 1 unit change in GRE, the log odds of admission increases by 0.002. Take a look at that. Log odds of admissions for every unit change in GRE. So GRE increases, GRE value increases, the log odds of getting admission increases by that, log odds. So that is what they mention in here. For 1 unit increase in GPA, the log odds of being admitted to graduate school increases by that. Okay. Now take a look at that. The indicator variable for rank have the indicator variable for rank have a slightly different interpretations. For example, uh, having attended an undergraduate institutions with a rank of 2 versus an institutions with a rank 1 changes the log odds admissions by this. So that is the way you have to give the explanations of the parameter estimates. Okay. So this is parameter estimates is gone, and then this is the most important part you have to explain. Now, log odds can also be explained as the odds by taking the exponentiation, which is mentioned in here, which is mentioned in this part. Now, what is Weld test? Weld test, just a second. করিম ভাই একটু পরে ফোন করতেছি 10 মিনিট পরে. Okay. So now, well test means one, there are 3 ranks, right? There are 3 ranks, there are 4, 5, 6 ranks. I want to compare among like this is called well test, well chi-square test. I want to check whether like the residuals that are coming, whether those residuals has the same mean or same variance, something like that. So that is this is what we are checking corresponding to these three ranks. Okay. So after that, we also do exponentiation. This is the what you need to explain. You can also exponentiate the coefficients and interpret them as odds ratio. Previously, all the coefficients are explained in terms of log odds. If you take the exponentiation, then it will be just odds ratios. So that is the way you can explain this in terms of odds ratios. Okay. And finally, there was some residuals, deviance, null models, those things has been applied, and this beautiful figure has been created. I have also asked you to create a figure like this way. So that's it. So again, let me explain these things to you for the last time, for the final time. So logistic regressions and probability regressions are very important predictive model in order to find whether the company is default or not, bankruptcy or not, there is a disease, no disease, all of these things you can obtain by using logistic regression and Probit models. Okay. So I have discussed how to derive this model mathematically, and also give two very short and concise examples so that you can understand in terms of simulated data or like the generated data. But I have given you a real life problem for the credit risks from a data that I have downloaded. So you just use my code, or I will be more than happy if you can do the homework by using Python and write a beautiful report. I'm going to stop here. Thank you very much. Bye.